Hello to all of you and welcome back to my SV2 channel. In this video, we're going to be looking at the mole and the Avogadro's number. So I have a kind of introduction to the mole as well as the Avogadro's number. We're going to be talking about the molar mass, how we can do the conversion between masses, moles, and atoms, molecules, or ions. And we also have a practice for you at the end. Okay, so let's get started by introduction to the mole. In everyday life, we use counting units such as dozens, 12 objects, score, 20 objects, or even if I have a pair, that will be 2 objects. In chemistry, the counting unit for numbers of atoms, ions, or even molecules is the mole. So 1 mole is the amount of matter that contains as many objects as the number of atoms in exactly 12 grams of isotopically carbon-12. Experimentally, our scientists have determined this number to be 6.0221425 by 10 to 23, and we typically round this to 6.02 times by 10 to 23. Okay, now scientists call this value as the Avogadro's number in the honor of the Italian scientist Emilio Avogadro. Okay, so let's talk a little bit more about this Avogadro's number. This number is often used with the unit of reciprocal moles. You can either say inverse mole or per mole, right? And that means we always need to keep that in mind that there are 6.02 by 10 to 23 objects if we have 1 mole of anything, right? So a mole of atoms, a mole of molecules, or a mole of anything else, right? They all are going to contain the Avogadro's number of objects, right? So for example, if I have 1 mole carbon 12 atoms, that will be 6.02 by 10 to 23 carbon 12 atoms, right? If I have 1 mole of water molecules, that would give me the exact same number. So 6.02 by 10 to 23 molecules of water. If I have 1 mole of nitrate ions, I'm going to have 6.02 by 10 to 23 ions of nitrate. Okay, so if that makes sense, now we're going to be looking at the molar mass. So remember we said a dozen is the same number, which is 12, right? And I can say I have a dozen of eggs or a dozen of elephants, right? But we know that they are not going to have the same mass. Okay, so similarly, a mole is always the same number, 6.02 by 10 to 23. But if I have 1 mole sample of different substances, they're going to have different masses. To consider this, we're going to go by molar mass. So here it says the mass is grams of 1 mole of a substance, and we're going to call that the molar mass. And the unit is always going to be grams per moles. Now, in chemistry, we often need to convert our masses to the moles, or maybe from the moles to the number of atoms, molecules, or ions. So this slide is going to give us a really nice summary for conversion between these 3 pieces. So if I have grams and I'm trying to get the moles, I need to use the molar mass, right? And you can say if you have the moles and you try to get back to your grams, you still need to use the molar mass. But if you have the number of moles and now you try to figure out the number of atoms, right, maybe the number of molecules or even ions, then we need to use the Avogadro's number. Okay, so let's take a look at this example. The question here is how many copper atoms are in the old copper penny? We have the mass of penny as 3 grams, and let's assume that we don't have anything else other than copper. So it's a pure copper penny. Okay, so I'm looking for the number of carbon atoms here. And I know that I have 3 grams of copper. And then I'm going to use the molar mass, which is 63.5 grams of copper, right? And I got this from the periodic table. And that is going to give me 1 mole of copper. Now keep that in mind. The units that we are trying to set up here, we have to be very careful with that. Whatever is this unit, it must be the same as the one that I have in the denominator. so that I can cancel them out. Okay, I'm going to talk about the unit conversions and all of these kind of unit analysis questions in a lot more in our future lectures. Okay, and then looking at here, you've got 1 mole of copper. The units that I have here must be consistent, right? And then you would use the Avogadro's number, which is 6.02 by 10 to 23. That would give us the number of atoms of copper, right? Okay, and when you do the math, we're going to have 3 by 10 to 22 copper atoms. Okay, cool, cool. So I've got another practice for you on the next page. Follow me on the next page, please. Okay, so here is our practice. It says, without using a calculator, arrange these samples in order of increasing numbers of carbon atoms, and I have 3 options. So for option A, we have 12 grams of carbon. Using the molar mass of carbon, we're going to get 12 grams per mole. That means we have 1 mole of carbon, which is going to be 6.02 by 10 to 23 carbon atoms. For option B, I have 1 mole C2H2. But because this molecule has 2 carbon atoms, I need to double my Avogadro's number. And that will be 12.04 by 10 to 23 carbon atoms. For option C, we have 9 by 10 to 23 molecules of CO2. And because in your CO2 there's only 1 carbon, that sample is going to have 9 by 10 to 23 carbon atoms. And if you try to rank them in the order of increasing the numbers of carbon, it's going to be A, and then C, and then B, which is the one that has the highest number of carbon atoms. Okay, thank you very much for watching this video. If you found this video helpful, don't forget to give it a thumbs up. You can share that with your friends, right? If you enjoy the content and you want to keep learning with me, you can hit that subscribe button, right? You can turn on your notification bell so you're not going to miss out any of our future videos. As I told you before, I always would love to hear from you guys. You can drop a comment below if you have any questions or like a specific topics that you would like me to cover that in our next video. Your support means the whole world to me and it helps this channel to grow. Thank you so much, and I'll see you around. Bye for now.